Okay, so when the oxide of a generic metal is heated at 25 degrees Celsius, only a negligible amount of M is produced. So just rewriting this reaction here for our own purposes. I'm just going to migrate it so I don't cut it off. Okay. And now when it's coupled to the conversion of elemental oxygen to CO2, which has a delta G value of minus 394.4 kilojoules per mole. It becomes spontaneous. So it wants us to write the balanced chemical equation for that coupling. So we really just add these up and cancel the ones that'll be the same on both sides. So now we have MO2 plus N solid plus CO2 gas. And our delta G for the reaction, we can also just add up. So our delta G is then minus 107.9 kilojoules per mole. And it wants us to show, to find the equilibrium constant. So the delta G is negative, so it is spontaneous. But then for the equilibrium constant, delta G is minus RT ln K, where K is our equilibrium constant. Okay, so then we've got all the values. For R, I'm going to use 8.314 joules per mole Kelvin. And for T, it says in the question 25 degrees Celsius. So it's 25 plus 273.15, which is 298.15 Kelvin. Okay. So then ln K is our delta G, which is minus 107.9. So it'd be, the minus sign needs to be carried over as well, so that minus would be there as well, and those would cancel. Over RT, so 8.314 joules per mole Kelvin times our temperature, which is 298.15. That's in kilojoules there, so we need to multiply the top by 1,000 joules per kilojoule. So the kilojoule will cancel, the moles will cancel, the kelvins will cancel, and the joules will cancel. So it'll be unitless, which is good. So this value on the side comes out to be, when we run it through our calculator, 43.53, which gives us a K of e to the 43.53, which is like 8.03 times 10 to the 18. And remember, the more it's greater than 1, the more it favors the products. So heavily favors products. Okay, I think that was everything. So going down through this, so there's our coupled equation, which we have. We can get our delta G by just summing them. And then we get about, that I think is just the difference in the decimal places used for a Kelvin definition. Yeah, because our delta G is the same, but it's about 8 times 10 to the 18, so it looks good. Okay,